Hi, everybody. In this video, I'm going to go over the Unit 3 practice exam with you. This practice exam will cover section 6.1 to 6.3, and the questions do go in order of the section. So we're going to start off in section 6.1 and then as we work our way through, we'll cover 6.2 and then 6.3. All right, so the first question says, for the two shapes below, write a fraction to approximate the shaded portion as a part of the whole. All right, so they're asking us to write the fraction as the shaded portion over the whole. All right, so for the circle, we can see that it's been broken up into 1, 2, 3, 4 parts, and one part is shaded, so that's 1/4. All right, so that one's straightforward. This one is a little bit harder. As you can see, the top line has been broken up into 3 squares or 3 rectangles, and the bottom line has been broken up into 2 rectangles. Now, none of these up here are shaded, so I'm not really considering them as part of my shaded portion. So instead, what I'm going to do is I'm going to redraw my sections. I'm just going to ignore these 2 lines here. All right, so since my shaded portion is down here in the bottom, I'm going to use that as my units. And so you can see what I'm really doing here that makes it look a little bit better is I'm just ignoring these lines. All right, and I'm turning that into a rectangle that's been split into 4s. All right, so if I'm looking at the shaded portion relative to the whole thing, I can see that 1 out of 4 boxes have been shaded. Right, so if the units aren't the same, then you want to make sure and force those into the same size. And again, it just says approximate. It doesn't have to be perfect. We're just coming up with some approximation of the shaded area. All right, so next we've got number 2 says subdivide the figure shown on the right to show the equivalent fraction. All right, so this will definitely be on the exam. Here we've got a, let's see, 1, 2, 3, 4, 5, 6 hexagon. All right, so we've got a hexagon. On the left-hand side, it's been split into halves, and we've got 1 out of the 2 pieces shaded, so that's 1/2. Now this is asking me to split it into 6 pieces. All right, so I'm going to do that just by connecting the dots here or connecting the corners. All right, let's make sure that's 6. 1, 2, 3, 4, 5, 6. Yep. All right, and I'm supposed to shade 3 of those. All right, so I'm just going to take something and shade those. It doesn't matter what color you use. You can just use your pencil. Doesn't matter which 3 you shade. If you want to make it match up with the one on the left, you could have shaded these bottom 3. But any 3 that you shade are totally fine. All right, so we have subdivided the figure to show that this is an equivalent fraction. All right, so definitely expect to see something like that on the exam, just with a different shape. All right, number 3, write 3 fractions that are equivalent to 2/7. All right, so again, this is another one. Oh, I see the numbers got messed up. This one's labeled as number 3 as well. So this one will be on the exam as well. All right, so 3 fractions that are equivalent to 2/7. You may all come up with different answers here, and that's totally fine. What I'm going to do is I'm going to take 2/7, and to create a fraction that is equivalent to that, it's just going to be a multiple of this fraction. So, for example, I can multiply the top and the bottom by 2 to create a multiple of 2/7, 4/14. You can multiply it by 3 to get another equivalent fraction. Multiply top and bottom by 3, that gives you 6/21. All right, and then I'm going to multiply by something different this time. I'll multiply by maybe -1 2/7, multiply by -1 on the top and the bottom. That gives me -2/-7. So here's my three fractions that are equivalent to 2/7. Right, and you don't have to come up with these three. You can do any numbers you want here. So you can do positive numbers, like I did here. You could do negative numbers. You don't want to do 0 because that's going to cancel out. That's going to 2 times 0 will be 0, and 0/0 doesn't make sense. You can't divide by 0. But you can do any positive or negative whole numbers here to come up with these multiples. So multiply by any positive or negative whole number. Number 3 is a little bit different than what we did in class, but I thought it was a great example of where someone might use fractions in real life, something that you could show your students for an application of fractions. It says, this is a typical English ruler, which is marked in 1/16 of an inch. Use what you know about equivalent fractions to locate 3/8 of an inch on this ruler. All right, so it's this typical English ruler is marked in 1/16 of an inch. So that means that this is 1/16. So this is 1/16 of an inch. This line is 2/16 of an inch, then 3/16 of an inch. All right, and then so on. This is 4/16, 5/16, 6/16, 7/16, 8/16, and so on, all the way to 16/16, which would be 1. All right, so if I want to know where's 3/8 of an inch, then I need to change this bottom number into 16ths because that's what my ruler is marked in. It's marked in 16ths of an inch. So to get from 8 to 16, I had to multiply by 2. So do the same on the top. All right, so this tells me that 3/8 of an inch is the same thing as 6/16 of an inch. All right, so go to your ruler. 1/16, 2/16, 3/16, 4/16, 5/16, 6/16. So this line right here would be 3/8 of an inch or 6/16 of an inch. So I do like this example. I like this example because this is one way that you can demonstrate equivalent fractions, and it's a visual example. So I'm going to circle this one as well. So I'll do this one on the test, and then I'll just change 3/8 to a different number. Right, so all you got to do is make the denominator 16. So figure out what do you need to multiply by to make the denominator 16. Do the same thing to the numerator, and then locate that point on that line on the ruler. All right, 4 and 5 are very similar. I do like this one, so I'm going to circle 4 and 5. Again, they're very similar, so I'm going to pick one of these. So I'll pick one of those to put on the test. Number 4 is very straightforward. It says fill in the figure so that it illustrates 3/5. All right, so we want to do our shaded portion is 3, our whole is 5. All right, we have 1, 2, 3, 4, 5 circles here. So very straightforward. Just fill in 3 of them or shade 3 of them. There we go. That's 3/5. All right, number 5 is a little bit more complicated. It says fill in the figure so that it illustrates 3/5, same fraction, except this time we're given 10 circles. So we need to make our whole match 10. All right, so it's shaded part over the whole. So if we want to change 3/5 into something over 10, we need to multiply top and bottom by 2. 5 times 2 gives you 10, so that tells us, okay, we need to multiply the top by 2. So that means 6/10 is going to be our shaded area. So you're going to fill in or shade in 6 of these. And I'm kind of being sloppy here. But you get the point. All right, so if you need to fill in a figure so that it illustrates a certain fraction and the denominator does not match your units in your figure, make sure that you find that equivalent fraction like we did here to figure out what do you need to shade in. Right, number 6. Solve for x. I wasn't sure if we did any like this in class, but I thought it was a good example of equivalent fractions. And so you may feel like you want to cross multiply here, and that is fine. That is one way that you can do it. But an easier way maybe to do it is just to say, okay, what would I need to do to 3 to make that into 18? All right, so what would you do to 3 to make it into 18? You would multiply by 6, right? So to get from there to there, you would multiply by 6. So we're going to do the same thing to 2 in the top. We're going to multiply by 6. So that tells us that 2/3 is the same thing as 12/18. So that tells us that x is 12. All right, so you could also cross multiply to get that answer. Just take you a little bit longer, I think. I don't think I'll put that one on the test. I think I've done enough equivalent fractions problems. Number 7 says, explain why 25 cents. I've got a typo in here. I'll fix this before I'll fix this on your copy of the test, but this should say $1. So explain why 25 cents is 1/4 of $1, but 15 minutes is 1/4 of an hour. Why are these fourths not equal? All right, so I don't think I'm going to let you think about this one for a minute. So think about, why is 25 cents 1/4 of $1, but 15 minutes is 1/4 of an hour? All right, so this question is asking, why is 25 minutes not 1/4 of an hour? Or why is 15 cents not 1/4 of $1? All right, so I want you to think about this one. So I don't want to give you the answer straight away, but what I want you to think about is, what is 1 whole? What is 1 whole for $1? And then same thing, what is 1 whole for an hour? One whole for $1 is 100 cents. 1 whole for an hour is 60 minutes. All right, so I'm going to leave it there. I think you probably have the answer already, but this is more of one where I just wanted you to think about, why are those not the same? Not necessarily something that I would put on the test, but just something I wanted you to think about. All right, so number 8 says, perform the operation, show your work. Write your answer as a mixed number if necessary. You do not need to simplify your answer. All right, so I'm going to do one, or actually, let me do B and C. I'm going to do B and C. So if y'all remember the little butterfly trick that I taught y'all, remember how they said to do this? They said multiply those. Is that right? Yeah, I'm pretty sure that's right. All right, so the way we did this is we multiplied the denominators together to get our denominator. So 12 times 3 is 36. And then up here we had 3 times 4 is 12. 12 times 1 is 12. So what is 12 minus 12? That's 0, right? What's 0 divided by 36 is 0. You don't have to simplify it. You could leave it here. but that one's really easy to simplify. Now, this one is a mixed number, so we are going to convert these to improper fractions first. All right, so 7 1/4 plus 3 1/3. So 7 1/4. To convert that to a mixed number, you're going to start, to convert that to an improper fraction, you're going to start in this denominator. 4 times 7 is 28, plus 1 is 29. Denominator stays the same. Plus, starting in this denominator, 3 times 3 is 9, plus 1 is 10, so that's 10/3. So now we're going to do that butterfly trick again. All right, so multiply those denominators together to get your denominator. 4 times 3 is 12. 9 times 3, what is that? 29 times 3 is 87. Plus 4 times 10 is 40. All right, so that's, see, 127, I think. Yeah. 127 over 12. All right, that is an improper fraction, so we do need to convert that to a mixed number. You're going to do long division. So I'm going to go down here and do 12 into 127. This one I think is pretty easy because I know that 12 times 10 is 120. So this has got to be 10 up here, and that would be 120. That leaves me with 7. So that's 10 and 7/12. All right, so this is the amount of work that I want shown for the test. All right, so it doesn't have to be anything super detailed. You don't have to tell me like, oh, I'm using the butterfly method here. Just as long as I can tell that you're not using a calculator and that you are working this out by hand, then that's what I'm wanting to see. Number 9. Oh, I forgot to tell you which one of those would be on the test. Let's say B and C. This one covers subtraction. This one covers mixed numbers and addition. So I like that combination. All right, so number 9 is kind of an estimation problem, which I told you would not be on the test. But I liked this problem, so I decided to include it. And it says, you're making 2 recipes for Thanksgiving. One recipe calls for 1 1/2 cups of milk, and the second recipe calls for 1 3/4 cup of milk. You check the refrigerator and you only have 3 cups of milk. Do you have enough to make both recipes? Explain your answer. All right, so for our recipe 1 and recipe 2, the first recipe needs 1 1/2 cups of milk. The second one needs 1 3/4 cup of milk. All right, so if I add my whole number parts together, 1 and 1, I know I need at least 2 cups of milk for sure. Additionally, over here, I've got 3/4 of a cup of milk. We know that's almost a whole cup. In addition to that 3/4 of a cup, I need another 1/2 cup. So I've got almost 1 cup plus another 1/2 cup. So almost 1 cup plus a 1/2 cup, that would be approximately 1 cup. So we're going to say approximately. So we know it's a little over 1 cup. So this would be, let's approximate that at 1.5 just to be a little bit more accurate. We're definitely not going to have enough milk. All right, because we're already at 3 1/2 cups of milk and we were just approximating. So no. And then my explanation here is just that I see that I have 1 plus 1 is 2 cups. This is almost a cup plus another 1/2 cup. This is not going to work out. All right, so not on the test, but a good application of estimating. Number 10. Number 10 is not an estimation problem. They want to know the exact amount. It says Joey has 3/4 of a cup of paint in a container. He uses 1/3 of a cup on a project and then adds in another 1/2 a cup. How much paint does he have in the container now? All right, so Joey starts out with 3/4 of a cup. He uses 1/3 of a cup, so he's subtracting off 1/3 of a cup of paint to use on that project. And then he goes back in and adds in another 1/2 a cup. So I want you to do this, one piece at a time. So go ahead and start by doing this part. Once you've done that, you can add in the 1/2. All right, so I'll leave that one for you to do. Number 11. Oh, I do want to put this one on the test, so let's circle that. Number 11, I like this one for the test too. You don't need to solve the problem. You just need to set it up for me. So it says write a story problem for 2/3 minus 1/4. You can do anything you want. You could say like one example is maybe someone gives me, my sister gives me 2/3 of a candy bar. All right, so 2/3 of a candy bar. And then I give 1/4 away to my brother. I give 1/4 of my piece away to my brother. How much candy bar do I have left? All right, so you come up with your own story here for this subtraction problem. It can be anything. It doesn't have to be cups. It doesn't have to be, candy bars like I just did. You can be creative and come up with anything you want. All right, next we have multiplication and division. Perform the operation. Show your work. Write your answer as a mixed number if necessary. You do not need to simplify your answer. All right, so we've got, let's do A and C. All right, so we've got 3 1/2 times 8. We need to convert 3 1/2 into a mixed number. So starting in the denominator, 2 times 3 is 6, plus 1 is 7. So that's 7/2 times. And then I'm going to write 8 as a fraction as 8/1. Then I'm just going to multiply straight across, multiply numerators, multiply denominators. All right, so that gives me 56/2. Oh, I need to make that into a mixed number. My bad. Let's do that. We'll go off to the side and do that. 2 into 56. 2 goes into 5 2 times. That's 4. Drop down to 6. Let's see. 2 goes into 16 8 times. All right, so minus 16 is 0. So my mixed number is 28 and 0/2, or just 28. Part C, 14/9 divided by 7/8. I'm going to keep, change, flip. Okay. I've made this into a multiplication problem, so I'm just going to multiply numerators, multiply denominators. 14 times 8. I'll try to pick better numbers for the test. I just picked these randomly, so that's why I'm getting these weird numbers. 14 times 8 is 112. 9 times 7 is 63. Oh, this is an improper fraction also. We're going to have to make this into a mixed number. 63 into 112. Let's see, 63 times 2 is 126. So it's not even going to go in one time. Or excuse me, it's not going to go in 2 times. It's just going to go in once. We're going to subtract 63. 112 minus 63 is 49. Right, so that's going to be 1 and 49 over 63. Okay. Next, on number 13, it says use the missing factor model of division to demonstrate why keep, change, flip works. I'm not going to put this on the test, but I put it on here just because I wanted you to have another opportunity to explore this concept. I think it's really cool and really interesting. So if you remember the way that we did this is we said, all right, well, if you took something simple like 30 divided by 2, the missing factor model of division says, think of this as 2 times what will give you 30. All right, so we're going to mimic that for our fractions here. 8 over 19 divided by 9 over 11. We're going to say, all right, so 9 over 11 times what would give us 8 over 19? 9 over 11 times what would give us 8 over 19? All right, and then if you remember how we did this in class, we said, okay, well, way back when we first learned how to do, when we learned how to manipulate fractions, when we first learned how to manipulate fractions, we learned that we can get rid of this 9/11 by multiplying it by its reciprocal. All right, so whatever we do to the left side, we've got to do to the right side. So let's go ahead and do that. But the reason that we do that, the reason that we multiply by the reciprocal is because these cancel each other out. All right, so 9 over 11 times 11 over 9, they cancel each other out. All right, and that tells us that the box is equal to 8 over 19 times 11 over 9. And then if you look, compare this to your original problem, that is keep the first one the same, change the operation from division to multiplication, and then flip the second fraction. So this is keep, change, and flip. So we've just demonstrated using the missing factor model of division why keep, change, flip works. So keep, change, flip is really just an application of the missing factor model of division. Really cool. All right, and then our last page. I want to say that I'm going to do both of these. So go ahead and circle those. I'm just going to count up really quickly how many I circled. 1, 2, 3, 4. All right, so I'm counting 13 that I've circled. I'm thinking I'm going to do 12 questions on the test because, let me show you one, even though I circled 13, because for 4 and 5, I was only going to pick one of those. So if you just count that as one problem, then that leaves you with 12 questions on the test. So number 14, sorry. Jasmine is reading a book. She's finished 3/4 of the book and she has 82 pages left to read. How many pages has she already read? All right, so let's use the bar model here. Break this bar into 4 pieces. Ideally, they would, the sizes would match, but obviously I didn't do a very good job of that. All right, she's already finished 3/4 of the book. All right, she's already finished this. So this is the first 3/4 of the book. And then she also has 82 pages left to read. All right, so that's the ending of the book. But each one of these quarters represents the same amount of pages. So that tells me that each one of these quarters represents 82 pages. All right, so now I'm just going to answer the correct question here. It says, how many pages has she already read? All right, it would be so easy here to just add them all up to get the total number of pages in the book. But they're actually wanting to know how many pages has she already read. So that's going to be these pages here. So add those up, 82 plus 82 plus 82. All right. That's 246. So Jasmine has already read 246 pages. All right, I'm going to do something very similar to this on the test. I might change the fraction of the book and make it like 2/3 of the book. And she has a certain number of pages left, but it'll be very similar to this. All right, and then number 15, if you have 22 3/8 inches of ribbon and you need 1 1/4 inches to decorate one Christmas ornament, how many ornaments can be decorated and how much ribbon will be left over? All right, so our whole roll of ribbon is 22 3/8 inches. And we need to use 1 1/4 inches to decorate our Christmas ornament. We want to know how many ornaments can we decorate. So we're going to divide by 1 1/4 to figure out how many ornaments we can decorate, and then we'll figure out how much ribbon's left over. All right, so in order for us to divide these, we need to convert them first into improper fractions. So do that first. 22, see, starting down here, 8 times 22 is 176, plus 3 is 179, divided by, then convert this into an improper fraction. 4 times 1 is 4, plus 1 is 5. Right, now you're going to do keep, change, flip. So now multiply that. 179 times 4 is 716. 8 times 5 is 40. All right, so let's do long division to figure out how many ornaments we can make. All right, so 40 into 7, that doesn't work. 40 into 71, that can go in one time. Subtract off 40, leaves us with 31. Drop down to 6. Let's see, 40 into 316. 40 times, I'm just thinking 4. 4 times 8 is 32, so it's probably 40 times 7. Let's see, 40 times 7 is 280. All right, so minus 280. Subtract that, that's 6. 3, 36. All right, so that is smaller than my divisor, so I know I'm done. All right, so this tells me that I can make 17 ornaments, and I've got 36 over 40 inches remaining. So I can make 17 ornaments. Sorry, I was running out of space there. So I can make 17 ornaments. And then if you want to reduce that, you can. What would that be? 36 over 40. That would be 9/10 of an inch. Almost a whole inch left over. All right, so we can make 17 whole ornaments. And then our remaining ribbon that we have left over is 36 over 40 inches, which if you want to reduce it, you can. You don't have to, but that corresponds to 9/10 of an inch left over. So for this one, again, I'll try to make this, the numbers a little bit better. I'll definitely make this smaller, so you don't have a huge number like 716, but it'll be very similar to this, where you'll have some whole piece of ribbon or whole piece of something, and you have to divide it up by a certain amount. All right, if you guys have any questions over this practice test, or if you need me to elaborate or explain something in a different way, please email me. Otherwise, don't forget that you can turn this completed practice test in for 5 bonus points on our next test. And I will see you after Thanksgiving break. Have a great day.